Hi there, guys. I realize we have a double block today. Unfortunately, I'm sick. My young daughter's sick, and I figured this is better than coming and spreading germs all over. It's just a cold. Don't worry about me. I know you were worried about me. I'll be back. I'm planning on seeing you Thursday. Now, I do have to say up front here, I feel like a bit of an idiot because I'm teaching calculus in my living room to nobody. My daughter suggested I get some of her stuffed animals and arrange them around to pretend they're my students. But, I just couldn't take all those just blank stares and no expression or anything like that. So, no, I'm just kidding. Anyways, hopefully you can get something out of this. I have never tried this before, so here we go. Anyways, last time we started talking about limits. And hopefully you started to develop a sense of an intuitive understanding of what a limit is. When you have a function, we looked at this rock falling off of a cliff, and we were looking for the instantaneous speed of the rock at a given moment, at 2 seconds, I think. The way we found that was we wrote an expression for the average slope between 2 points. And use this, right? So we wrote an expression for the average slope between 2 points. I think we used 2 and 3 or something like that. And to try and approximate this, right? There's the average speed. And then we pushed this down closer and closer, as in we made the difference between the two x values, which we were calling h. H was the difference between the two x values. We pushed that closer and closer together. The limit of that expression that we wrote, the limit as h approached 0, the difference in between, the limit as h approached 0 was the slope of that tangent line. The green line approaches that red line there. All right, we're going to look some more at limits here. I guess we got one whole page done last time, which is amazing progress. Speaking of rates of change, at that rate, we will never finish the course. So we better move on here. Definition of a limit. What a limit is, when you talk about a limit of a function, it's how a function behaves as the variable moves towards a certain value, one side or the other, or from both sides. This behavior, I know it's hard to think about how it behaves, how functions behave. We're going to look at this function. It's one that you probably haven't seen before, but if you graph that on your calculator, you have a sense of what it looks like. You could pause the movie and graph it and see what it looks like, and try and talk about what this might be before playing the video. Wouldn't that be a good learning activity for you? If you've done that now, you notice first of all that the graph sine x, you think it's going to look like the sine graphs that you've seen before, but the fact that you're dividing it by x ends up, I'll show you on here. I'm going to show you on this graphing program. At first it looks like a sort of the usual sine curve there. But as you go out to the right, we'll just compress this a bit here. You see that the waves get, pretty quickly, they get less and less high, right? It drops off here, and you end up, it kind of starts to trail out towards the end there. We're going to look at two limits with this function. The one you're looking at right now, I'm holding down shift because I have to. The one that we're going to look at first is the limit as you approach 0. As x gets closer and closer to 0, what happens to that function? Now, if I didn't tell you anything else about this function here, you'd probably guess, well, it looks like it's heading up here towards 1. That's what it looks like it's doing, right? But as you move this point, whoops, I gotta grab a hold of that point. How come I can't do that? No idea. That's very interesting. perhaps we'll pause for just to take care of these technical difficulties. Well, I realize that wasn't a pause for you, but it was a pause for me while my computer and me had a little talk. And I did want to keep this a G-rated movie, so it's best that we pause there. Now, I don't think there's any missing this point here, and we have sorted it out. So this is not really a point, but it's meant to represent one here, and it shows you the coordinates on that curve. Now, what happens as you get closer and closer here? Now, this thing snaps to, it's going to snap it to 0. And what happens when you get to 0 is it says that this thing is undefined. Not sure if you thought about it yet, but that function is undefined when x is 0. X is on the bottom of this fraction here. Sine x divided by x. X is 0. Can't divide by 0 there. Now, actually, you think about sine of x on the top of the fraction. They're both 0. It's 0 over 0. Now, before you say, oh, look, well, 0 divided by 0 should be 1 here. Later on in calculus, if you continue to take it at a university course, you look a lot at things like that where you have 0 divided by 0, infinity times 0, and other things that they call indeterminate forms. This function here, actually, on your calculator, if you graph it, it shows a little hole in the graph there. Which we can do here pretty quick. If you graph sine x divided by x, make sure you're in radian mode. I would just do, if you do, who knows, do zoom trig maybe. Let's try that. And see what it looks like. Now, you don't need to actually, we could make this window not go quite so high here. It only really needs to go up to, well, it doesn't even need to go down to this, but negative 0.5 and then up to 1.5 maybe, to see that middle part of it. Now, you still can't see that hole in the graph, except if you do this. If you turn the axes off here, okay, under format, and you go here and turn the axes off. Not that you'd ever want to do this, but okay, you see that there's that little break in the graph. On this super high resolution TI-83 Plus HD screen, you can see that there's 1 pixel missing there. That's the missing point, right? If you're to trace along that in the middle, right, the cursor's there, and then when you get to the middle, there's no y value there. It's undefined. All right, it's undefined, but the closer and closer you get, the more it looks like that function is headed for that point. It's undefined there, but it's headed for that point. As you go up this curve from the right, it looks like the function's headed for 1. As you come from the left, it looks like the function's headed for 1. Even though it's undefined there, you'd say that the limit as you approach 0 is 1, because that's how the function's behaving as you get close to that. All right, let's go back to this. Okay, remember we said it's how a function behaves as the variable moves towards a certain value. The limit of that function, okay? So if you put your quick little graph down here, there's actually a little hole in the graph there. That is a beautiful graph. Drawn so well. As you get closer to 0 from either side here, the function is headed for 1, even though it's undefined. Heads for 1, even though it's undefined. So you'd say that the limit of that function is not 0. As you approach 0, it's 1. All right, even though the expression itself, even though the function itself is undefined at that point. You can look at a table. Numerically means looking at a table. If you look at a table for yourself on the calculator, if we have time here, start at -1, go by 0.1, set this up. Okay, as x gets closer to Okay, you notice it says it's undefined there, but those values are approaching 1 as you get closer there. All right, we're going to look at another function in a second here in the next part.